Think for a moment about your parents or your grandparents. For them, getting an infection isn't just inconvenient, it can be life-threatening. During COVID, we all saw how age was the strongest predictor of who survived and who didn't. And the same is true for cancer. Aging doesn't just add years, it changes the very defenses meant to protect us and increases our vulnerability to life-threatening diseases. Raise your hands. How many people here know someone who has had cancer or someone who died from cancer? Look around you. That's a room almost full of hands. 10 million people die from cancer each year, and that number keeps growing. Can you imagine if cancer was an infectious disease? We would be terrified, right? We would declare global emergency. But instead, as a society, we have accepted cancer as part of life, although it's devastating. And despite all the headlines about breakthrough therapies, the reality is that progress in cancer treatment is still incremental at best. And often the therapies that are available don't even work for the elderly population. This is so evident because despite decades of innovation, cancer is still primarily a disease of aging. You can see in all of these graphs behind me that for many, many types of cancer, the death from these cancers spikes when people are above the age of 60. So what this tells us is that we truly need a radical shift in the way we tackle cancer, while taking into account aging as an important factor. For decades, we believed that aging means unavoidable immune decline. So we accepted living with the idea that cancer is unavoidable too. But do you remember when people once accepted polio as part of life until science changed history forever? Now imagine that we can do the same for cancer. Let us tell you how. My name is Dania Zhivaki. When I was a scientist at Harvard Medical School, we made an important discovery that turned upside down everything we thought we knew about aging immunity and cancer. We discovered how to give your 80-year-old immune system the fighting power of a 20-year-old. Now we know how to turn back the clock. And this is not science fiction, but a breakthrough that is being developed into treatment and that should be available to patients and people within the next few years. Nick and I are part of a terrific team working together to revolutionize medicine around this idea.
What we're developing is part of a brand new field called in vivo T-cell engineering. That's a bit of a mouthful. Let me break down what that actually means. Think of your immune system as an elite fighting force. Let's focus on two key players. They're the generals who assess threats, strategize, issue orders, and then there are the soldiers who go out and actually fight on the front line. In your immune system, the generals are called dendritic cells. The soldiers that go attack cancer are called T-cells. When you're young, this system works very well. The dendritic cells are sharp, there are lots of T-cells. But as you get older, this system declines. There are fewer and fewer T-cells, and the generals, the dendritic cells, lose their edge. This is one of the reasons, as we get older, that we're more vulnerable to cancer and less responsive to treatment. The same thing happens with mice. As you can see in this experiment, we gave mice with cancer checkpoint inhibitors. This is the most successful immunotherapy. This graph shows the percentage of mice that survived over time. When we gave young mice checkpoint inhibitors, the green line, this treatment worked very well. 80% of the mice survived. But when we gave the same treatment to elderly mice, the black line, it didn't work. They all died, every single one. This is where our story takes a twist.
Meet the hyperactivators. We discovered what the journal Nature described as the elixir for aging dendritic cells. And this is inspired by a natural alarm signal that our body produces it naturally when cells are injured. So we made a refined version of it, And by delivering it, we can fix the problems of the elderly generals and restore immune functions to the elderly. When we combine these hyperactivators with cancer antigens, which are the unique identifiers of cancer cells, we achieved something unprecedented. We gave this treatment to elderly mice that have cancer. And instead of all of them dying, just like with the checkpoint inhibitors here in black lines, 80% of mice that received the hyperactivators rejected tumors and survived for so long. And this was the same success rate as the young mice that received the checkpoint inhibitors here in green. So what happened? What changed with the elderly immune system when they saw the hyperactivators? Here is where it gets fascinating. While majority of cancer research is focused on the CD8 killer T cells that normally fight cancer very well at a young age, we noticed something very different in the elderly immune system. These CD8 killer T cells become old, tired, and drastically decline in number. But what we found is that hidden in the aging immune system, a completely different defense force that nobody was paying attention to. The CD4 helper T cells. Our therapy transformed these helper cells into killer cells that hunted down cancer with surgical precision. And this is why the field is called in vivo T-cell engineering. Now we can reprogram in vivo, meaning inside our body, how these T-cells behave. And we can do it in a very precise and safe manner. Now this is the most exciting part. We gave this treatment to young mice and waited an entire year, which is the equivalent of 30 human years, and then gave them cancer. The result? Every single mouse that received the hyperactivator therapy rejected completely the tumors and survived with no recurrence for another year, which is another 30 human years. This slide, I don't think Big Pharma may love it. Because imagine getting a medicine in your 30s that doesn't just protect you against cancer for a couple of years, but programs your immune system to stay vigilant for life. Imagine an elderly patient whose immune system can be restored to fight cancer as if they're 25 again. And this is not just in mice. We tested these hyperactivators in the most challenging tumor models. We tested them in dogs, in non-human primates, and in human cells too. And we got the same success. These hyperactivators transformed dendritic cells from people above the age of 70 into cancer-fighting machines.
In sum, this in vivo T-cell therapy does three things. First, it treats cancer in a much more powerful and precise way, which means that it should also be much safer. Second, it gives new hope for the most vulnerable, as Dania described, including the elderly. And third, it generates durable immune memory through what are called memory T cells. Memory T cells are what stick around after you get sick to make sure that the disease does not return, like when you get chickenpox as a kid. No cancer therapy does this right now. For anyone who has successfully battled cancer, you know what it's like to live with the fear that your cancer is likely to return. Durable immunity means no more living with the fear of recurrence. And this isn't just for one cancer. This is a plug-and-play system that's broadly applicable across cancer types. These are just a few examples of success we've shown in difficult cancers. It's not just for one stage. It's as applicable to early stage 1 as it is to late stage 4 and everything in between. And there are implications well beyond cancer. Longevity experts are increasingly recognizing immune decline as the so-called fifth horseman, alongside heart disease, cancer, dementia, metabolic dysfunction. Basically, if aging had a dream team, this would be the lineup. You don't want them playing your home team. Most people think of the immune system as our protection against germs, which it is, but it's a lot more. As the immune system declines, it drives a lot of not so nice things. Autoimmune disorders like MS, lupus, diabetes, heart disease, cancer, dementias like Alzheimer's, psychological disorders like depression, arthritis, allergies, chronic inflammation, and more. The key point is, as your immune system declines, it drives aging itself. As we try to tame this fifth horseman, our hope is to profoundly reshape the aging process.
This research represents something way bigger than any single treatment. We've proven that the elderly immune system is not broken, it's different. And when properly activated, its extraordinary capabilities can be restored.
We're working right now with the biggest names in global health to make this a reality. This isn't some distant future. We go into clinical trials next year. Our vision is for all of us to mark our 80th birthday, not as a countdown to decline, but as a celebration of accumulated wisdom. Looking forward to going to your youngest grandchild's graduation, climbing Mount Kilimanjaro, maybe even playing baseball with your youngest great-grandchild. We can't promise you'll hit a fastball, but we want to keep you in the game, backed by an immune system as sharp as it was in your prime.
Thank you.